Okay, good morning. My next topic will be the troubleshooting of motors. Okay, the actual troubleshooting of motors. So the gadget that will be needed to troubleshoot the motor will just be simply the multi-tester. Okay, it's the multi-tester. So by using the resistance test, okay, we can troubleshoot a motor if it is still alive or not. Meaning, if the wiring of the motor is burned out, it will be an open circuit. If it is not, what I call this burn, it will be a closed circuit. And we can determine the winding of the motor if it's open or closed by using the multi-tester. So for this morning, I will be troubleshooting this vacuum cleaner here. It got a motor, okay? And the motor is connected by an extension wire, a long extension wire, okay? Hold on. Long extension wire, and it has a, what do you call this, uh, plug over here that will be plugged on the convenience outlet if we use it, okay, during the operation. So to troubleshoot this, what you call this, vacuum cleaner here, which has a motor, we will just use the so-called multi-tester. And to start troubleshooting the motor, okay, I will try to set my multi-tester on the ohm pointer. Okay, on the ohm pointer, the one we have discussed a while ago. Then I will try to place the or connect the terminals of the tester, okay, on the terminals of the plug. Okay. Uh, this vacuum cleaner don't have any more any switch, so I directly connect the extension cord to the motor. So the only way to switch on this one is to plug in. It will act immediately. So there's no more switch for this one. I did this. I removed the switch. Okay? Because the switch sometimes is actually the one creating the trouble. Right? There's a disconnection in the switch. You flip it close, but it doesn't, the motor doesn't run. But the problem is actually the switch. So what I did is that I removed the switch. So I directly connect all the windings to the motor without any switch. So the only way to activate this, what you call this, vacuum cleaner is just to plug in. If it is alive, it will run. Okay. So for the testing, it's straightforward. Just use your multimeter, okay? Place it on the ohm pointer for measuring resistance. And if the motor is alive, there should be a resistance reading that will come out on the tester. What comes out is 23.4 ohms. There is a reading, right? So if there is a reading, the motor is alive. Supposing the motor wiring is burned out, so if we try to connect, the reading should be OL, meaning it's overload or open circuit. So for a burned motor, when you use the so-called tester, the reading should be zero. No. It's an OL. OL for a multi-tester is actually overload. It's an open circuit. Okay? But luckily, when we connect the other terminal, there is a reading on the multi-tester. Okay? What comes out is 23.4 ohms. It's a low value because from this low value here, we could actually compute for the total current that this motor, what they call this vacuum cleaner, consume from the voltage AC of the outlet. It will just be simply 120 divided by 23.4. Okay? So the current is not so much. But since our testing by using the multi-tester on the ohms reading, there is a reading, so we could say that the motor is alive. So how do we know that the motor is alive? From the multi-tester reading, there is a reading, right? And to check it, or to check the validity of our answer, We will remove this one. Okay. We put our multitester on the side. So the only way we could verify if the multitester reading is correct or not, it should be correct because there is a reading. So supposed to be the vacuum cleaner is alive. So how do we know it's alive? Just plug it in. Right? Just plug it in. I plug it in. Then I switch on the outlet. Right? So the vacuum cleaner is alive. And according to our multitester, there is a reading. So the vacuum cleaner is alive. And we check it that it is alive by plugging it on the continuous outlet. The motor is alive. The motor is alive because there was a reading by using our multitester. So just in case the reading is there is no reading, okay, don't assume yet that the motor is dead. There could be a problem or the so-called an open connection on the wiring. I mean the extension cord. So try to inspect the extension cord. There could be a problem. It might not be the motor. But in this case, I am sure that the extension wiring was good because the last time around, I troubleshooted this one already, basically. Okay? So what I am showing you just tonight is actually how to troubleshoot a vacuum cleaner that involves a motor by using a multitester by setting this on the ohms location. So if there is a reading, the vacuum cleaner is alive, assuming that the extension cord is perfect. But if it's not perfect, try to inspect it. Okay? There could be some disconnection. If there are some disconnection or loose connection, okay, use your knowledge of soldering to properly connect it, then tape it very good so you will not be electrocuted. Okay? That's it. That's the proper way on how to troubleshoot a vacuum cleaner by using a multitester only. Okay? So actually, you could do this at home. Okay, good morning from Los Angeles.